Okay, hey, welcome to today's stream. I'm just setting up the files for today right now. So I usually just create a couple of template files so I can just copy paste the data in as soon as I get it, and then set it up so that I can run it on save. Cool. I think that's pretty much the file setup. Nice. Cool. So I'm not sure what to say right now. Again, this is like filler 5 minutes to kind of get the stream up and running and ready to go. I guess a little bit of reflection on yesterday's puzzle. Yesterday's challenge was quite cool, right? It was the same input, but interpreted in two different ways. And depending on that, you end up with a completely different result. And one of the bugs I ran into as I was doing this was in one part of my code, instead of doing switch the variable n, which was kind of part of the input, I had switch heading, which was a completely separate variable. And it kind of took quite a lot of console.log, like print line debugging, to find where that error was. And yeah, so I guess this is this is one of those things I think that different programmers do. Some programmers, especially ones who are used to like languages with good integrated development environments, IDEs like Java or .NET, that sort of thing, then this, like, using the debugger is a very straightforward way to resolve these problems because it lets you step through the code and things like that. And I'm aware that there probably are ways to do that in JavaScript as well. But what happened was, like 5 years ago, I started programming in Scala, and this was back in the early days of Scala, right? This was like Scala. I'm not sure what the version numbers are. Like it was 1.12 or something like that. Like this was back in the days where like you could use Scala with Eclipse, and you could kind of get debugging in there, but it was a little bit janky and kind of really slow. And so I kind of got used to print line debugging, and then I switched to Go. And when I was using Go, again, I'm pretty sure Go has good debugging support. I think like if you use Visual Studio Code, VS Code, right, and you could get like a plugin that lets you like step through your code and all that sort of thing. So I know it exists, but I kind of was that kind of stubborn person who just wouldn't get off Vim. And it's a little bit tricky to get all that integration stuff working in Vim unless you have the patience to sit down and work it all out. And so I never did. And so yeah, I kind of got used to just doing this print line debugging thing, or in JavaScript's case, console.log debugging, which is kind of a little bit frowned upon, I think, as a professional developer. But on the other hand, like because I did this for so many years, I got good at like looking at my code to find my mistakes. And usually like I can still find it, and only every now and then I have to really do a lot of print lines to find it. Yeah, so yeah, apparently VS Code has really good JS debugging. And I think this is one of those things that's like very personal, right? Some developers are really good at using those tools, and you're really efficient at it, and you can step through and find errors really fast. Like, that's really cool. All the power to you. Yeah, it's just for me, like the learning curve for learning to use those tools and using them efficiently, I find that a little bit of a challenge. Maybe I'm getting old. I'm not sure. I'm older than I look. I'm almost turning 30. So there you go. Anyway, today's challenge is up. So let's go. Let's see what we get. That's enough of my rambling. Oh, it's lagging. So I'm just gonna go straight to the page. I'd hope that's not my like internet, eh? No, okay. Oh no, did the servers crash again? That'd be a bit of a downer, because I'm actually quite excited today. I'm like really in a programming challenge mood right now. So I'm just gonna wait for it because I don't wanna like spam this server. It is not my internet, right? No, it's not my internet. Well, it can't be my internet, I'm streaming. Oh no. It works fine for you? Alright, maybe I'll just hit refresh. Like, it's not me, right? Like, I can, yeah. That's a bit weird. Maybe it's my... Ah, okay, it's up. Yeah. Probably just a little bit of a... Yeah. It's loading for me. It's loaded for me now, so we'll just have to roll with what we got. So this is an interesting sequence of inputs. I'm gonna have to read the challenge to find out what it is. So my ferry has made it to a safe nearby port. Cool, but it won't go much further. When I look to book another ship, there are no ships that embark from that port. So I need to go from the port to the nearest airport. Fortunately, a shuttle bus is available. Each bus is an ID number, which also indicates how often the bus leaves for the airport. Bus schedule is defined by a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departs from the seaport. After that, each bus travels to the airport, then various other locations, then finally returns to the seaport to repeat its journey forever. Cool. The time this loop takes a particular bus is also its ID number. The bus with ID 5 departs at timestamps 0, 5, 10, 15, and so on. The bus with ID 11 departs at 0, 11, 12, 22, 33, and so on. If you are there when the bus departs, you can ride that bus to the airport. Your notes consist of 2 lines. The first line is your estimate of the earliest timestamp you could depart on a bus. Okay. I'll just call that timestamp. And then the rest of the input. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show X must be out of service, so you decide to ignore them. To save time, once you arrive, your goal is to figure out, so I'm going to do something like this, right? Just so I can, I'm going to replace all the X's with nulls, just to kind of have that as readable input by JavaScript. To save time, once you arrive, your goal is to figure out the earliest bus you can take to the airport. There will be exactly one such bus. For example, you have bus 7, bus 13, bus 59. Oh, okay. Some kind of greatest common denominator kind of problem, maybe? Here, the earliest time that you can depart is 9:39. Ah, that's the earliest. So we want to find the first thing after that we can find. These are the times marked D. The earliest bus you could take is bus ID 59. It doesn't depart until 9:44, so you need to wait 5 minutes before it departs. Multiplying the bus ID by the number of minutes you need to wait is 295. What is the ID of the earliest bus I can take to the airport? Multiply the number of minutes I need to wait for that bus. So what is... The nulls are weird. The nulls are weird, right? I'm just going to get rid of them. Like, bus IDs are... I'm just gonna chuck them in here as a list. Oh well, you know what? We'll do that. We'll do that programmatically. We're gonna do bus IDs equals input.filter everything that's not null. What's the problem here? Cannot read filter of undefined. Really? Yeah, because there's a null up here. That was a bit of a blunder. Cool, so those are my bus IDs. I want to find the greatest, well, isn't that quite straightforward, right? We can just take timestamp divided by this number, or timestamp mod this number, right? Oh, I don't want to mod this number. I want to do the other one. I'll just do divide. So the one that I can take is going to be the one that's closest, right? So it looks like the second to last one is the closest. So the second to last one is is 419. We can check this probably pretty easily. 4105595, I think it was. Yeah, so 2399 times 419 is that. So 1005595 minus 105181. 411, 414. That sounds right, right? I want 2400 times 419 minus 1005595, which I think was the number. Yeah. 5 minutes times 419 is 2095. I have a feeling this is wrong, but I'm going to submit it anyway. Oh no, it's right. Okay, it's good. Okay, let's carry on. So we did that with no program whatsoever. We just did it by hand on pen and paper, basically. Charlotte Company is running a contest. 1 gold coin for anyone that can find the earliest timestamp that the first bus ID departs at that time and each subsequent ID at the subsequent minute. For example, if you have to input that and X, then schedule means there are no constraints on what bus IDs must depart at that time. Ah. That means you're looking for the earliest times T such that 7 departs at timestamp T, 13 departs at timestamp. Oh, okay. That seems quite tricky. I need to look at my input to do this. 13 departs 1 minute after that. There's no requirements on the departure at 2 or 3 minutes after timestamp, but then bus ID, the next one, must depart the time after. The only bus departures that matter are the listed bus IDs at their specific offsets T. Right, so because in this example, it's 713XX59. So 715XX59, and then X3119. Here are some more examples. However, with so many bus IDs in your list, surely the actual earliest timestamp will be larger than a lot of zeros. What is the earliest timestamp such that all listed bus IDs depart? Ah, okay. This is a numeric problem. So there has to be a mathematical solution to this. We want a number such that we're looking at multiples of 41, right? Then in this case, I'm going to guess that 1068781 is a multiple of 7. Yes. Okay. So we're going to look at, we need a multiple of 40. Oh, let's do this by hand. Let's do this by hand. I feel like we can do this by hand. We're looking for T that is that divides 41. Then we want T plus oh, we need to count this. T plus 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm gonna split this. Hang on. Here we go. Okay, so this is on line 4. So 4 is 0, right? So minus 4. Line number minus 4. So we want 35. T plus 35 is 37. T plus 35 has to divide 37. T plus 41 has to divide 557. T plus 43 has to divide 29. T plus 54 divides 13. Um, 13. T plus 58 divides 17. T plus 64 divides 23. T plus 72 divides 419, I think it was. What was it? 419 after 23? Yep, 419. Cool. And T plus 91 divides 19. I'm sure there is like a really simple mathematical way to do this, but it eludes me because I have to really think about it. I'm sure there's a way to like just multiply a bunch of numbers together to get this result. Let's look at the example. Maybe that will help. We want t that is divisible by 7 and t plus 1 that is divisible by 13. I kind of want pen and paper to do this actually. So I'm going to have to do this off screen because I really need to just scribble on something if I can find a pen. T has to be divisible by 7. T plus 1, that is divisible by 13. What does that mean? If I have 7 and multiples that are numbers that are multiples of 7 and 13. But I want multiples of 13 plus 1, right? No, let's do it the other way around, right? What we're saying is t minus 1 is divisible by 13. So t is divisible by 7, but then t minus 1, no, not t minus 1. T plus 1 has to be a multiple of 13. Seven times 13 is 7 times 13 is 91. It's nowhere near, right? All right, sorry guys, I'm just gonna have to like stare at this for a while. I feel like there's some modulus maths stuff we can do here. Ah, look, that's a bit of a result, right? Mod the bus ID would have to be the number minus that many time steps. That's 6 time steps, and then this would be 12, right? Yeah. Oh, that's a I want a number t when mod 41 is 0, when mod 37 is 2, when mod 557 is 513, when mod 29 is, and I feel like this loops around, right? 14, so I want 29 minus 14, which is 15. I want a number, sorry, I'm using the built-in calculator so you can't see it. What I'm up to, 29. I want a number mod 13 equals 11. I want a number mod 17 is 10. The way I'm getting 10, by the way, is 17 minus 7. So mod 23 should be 5, I think. And 419 minus 72 is 347. So mod 419 is 347. 15, 4. And mod 19 is 4. Seems like what I want. But I just want this simpler case first. I want a number that mod, what was it? What was the example case? Mod 7 is 0, and mod 13 is 12. See, you can check this very easily, right? Because like we could brute force it, but it's going to take forever. Maybe it won't take forever. Should we just brute force it and see what we get? And see what happens? We'll use this input to test. Example, x for example is 7, 13, null, null, 59, 31, 19. So we want mod for I less than x dot length, I plus plus. All we want is we want mod the first number to be 0. So let's put together targets. If xi, what do we want to do? Targets dot push xi, which is the 7, and then we want the mod, the result of the mod, right? And the result of the mod is the number minus, what am I doing? Is 2, and then 13 minus that is 11, which is what I wrote down. And it works for small numbers, right? Yeah. So we want the time difference, which is the index, mod the value. Okay. So we want this to be the index minus the value mod the index. You can't mod 0. Probably, something like that. 0 minus 0 is 0. If I is 0, we just push xi 0, else that. That's not right. It shouldn't be 13.1, it should be 13.12. I got it the wrong way around, didn't I? It's xi minus I mod xi. Yeah. And that is true, right? Because 106871, which I'll call t, t mod 59 is 55, t mod 13 is 12, t mod 31 is 25, not 26. That's weird. It should be 12. Did I type it in wrong? I did type it in wrong. There's supposed to be a null in here somewhere after the 59. So those are the targets. So for let I equals, we're going to set it 1,000,000, I true, I plus plus, we'll start from 0 just to see how long it takes. So we're just going to log out a number every 100,000. If for const div mod of targets, if I mod div equals mod console.log I break. Interesting. I mean, it should stop. I don't know why it's printing it. Okay, something is wrong. Is it a bracketing issue? That would be weird. Ah, whoops! I broke from the wrong thing. That's why. It works for 0. That's pretty funny. Right. Has to be true for all of them, right? So this is just to make sure it's true for all. We could probably do like a for all thing here, right? But yeah. You could do like a target start every div mod I mod div equals mod. If that console.log I break. Yeah, so we got there, right? That's the number we wanted. Do I trust doing this? So it said the answer was surely at least this number. So we can try that. Whoops. Instead of using x here, we're gonna say x equals input. So like, I mean, it can search pretty quick. Chuck an extra 2 zeros in here just to like, but like, we're never gonna find it like this, right? If we brute force. There has to be a simple way to like multiply numbers together. Hey Gabriel, welcome. Today's challenge is quite tricky and I'm finding it really hard. There has to be a mathematical solution. I just don't know enough maths to be able to figure it out. And I will feel really sad if I don't. Okay, so while that's running, I'm gonna go and try and figure this out on paper again. I guess what it means, right, is if it's mod 12, what that means is I want a number that's 13x plus 12. 13x plus, like the x can be anything, right? So 13x plus 12. So if I have a number n that divides 13k plus, like n divides a, b plus c, no, it doesn't divide ab plus c, right? It is AB plus C. So I want a number that is A times, it's like 7A for any value of A, which is also equal to 13B plus 12 for any value B, which is also equal to which is also equal to 59C plus 55. Which is also equal to 31D plus 25, which is also equal to 19E plus 12. Yeah, I'm probably going to be here for like an hour trying to figure this out. I kind of want to like pull up a graphing tool. But I'm afraid this is going to crash my computer. My computer isn't very, like Firefox, this is Firefox, and Firefox isn't very good at dealing with like heavy JavaScript loads on my computer, on my laptop for some reason. It just kind of freezes a lot. Right, and we want integer values of this, but this is always going to be integer values. We want integer values of x and y. See, so it does give me a set of answers where this works, right? Can I like honestly, if I chuck in another variable in here, like is it happy to solve it for me? It is. You know what? Like, you reckon I could just chuck like every single like number in here, and then get WolframAlpha to just work its magic and do it for me? Right, and so if I chuck n in there, right? So n is 1. So 102011. I need a thing in here. Right? 102011 plus 344776. That's not the number I wanted, is it? Like P, Q, R, S, T. Ah, okay. So maybe I just ran out of letters. Let's try this again. A, B, C, D, E. Ah, right. I need like letters that it's happy to like treat as variables. It's too many dimensions. It doesn't like it. How would you solve this on paper? For integer over integers, right? Solve this over integers. And if I extended this with another one, like, do these all give me the same results though? Like 7 times 817, and then 13 times 439 plus 12. I don't think this is giving me what I want. But it gets the second half right, it just doesn't get the first half right. Maybe it can't do like multiple equal signs. Oh, whoops. 7 times 817. Huh. 5719 mod 7 mod 13 mod 59. So it can do that. It can do 3 variables. Can we do 4 variables? So if 7 times 33798, and we have 18198 times 13 plus 12. It's the same number. So maybe it does work. Maybe I just read it wrong. 7 times 451,763 plus 152,683. See, but that's way too big, right? Or was it? The example answer was 1 million. And this is, oh, but n can be 0, right? N can be 0. Integers, right? 152,683 times 7 is that. 822,13 times 13 plus 12 is that. All right. Okay. Looks like WolframAlpha can do this for us in the end. It's not as satisfying as coming up with the algorithm yourself. We do have like 1, 2, 3, 4, 5, 6, 7, 8, 9 variables. I don't know if WolframAlpha will be happy to do this for over 9 variables, but 41a equals 37b plus 2 equals 557c plus 513 equals 29d plus 15 equals 13f. I can't use e because it interprets it as an exponential, as a times 10 to the power of thing, plus 11, which equals 17g plus 10. I'm going to do 6 variables and see if it likes it first. If it's happy to do 6 variables, like I can see it like slowing down. Equals 23h plus 5 equals 419hi. I can't use I. J plus 347, which equals 19k plus 4. All right. Fingers crossed. Oh, it's too much. It's too much for it. One, two, three, 4, 5, 6, 7, 8 dimensions. It's okay. What we can say is that it's at least happy to go up to what's it? 41 times 63252,851. So we know the number is at least this size, right? 7009097 times 37 plus 2 is the same number. Look, we have this thing here. We have everything in terms of a. But how does that let you arrive at a solution? I don't know the maths behind this. Don't interpret that as a complex number, please. But I kind of feel like it might. Interpreting as integers. Like, is it just too long? If I put brackets around it, will it try? I am at a loss. And now, like, if I stop now, I'm just gonna be really, really dissatisfied for the whole evening. Oh, maybe I could write it differently. At least you write everything in terms of A. But that doesn't help me solve it for integers. Oh, you can just rewrite everything in terms of A. Yeah, you can just rewrite everything in terms of A. What the? B is that, so times 13. Oh no, that doesn't work. I guess you could write B in terms of C. Substitute that in. I wish there was a clear. Okay. Okay, so there's this channel called three blue one brown, which you know, does a lot of does math problems. And one of the things that he always says is, when you have a complex problem and you want to figure out a way to solve it mathematically, break it down into smaller problems and solve it from there. So 41a plus let's do the other one, because that one I can solve for. A is 13n plus 11. B is 7n plus 5. Now where did the 7 and the 5 come from? Is the question. Where do the 11 and the 5 come from? Because the 7 and 13 are obvious, right? If I chuck in a 50, let's do a small number, 19c plus 12. Is 247 going to be 13 times 19? It is. And then 19 times 7 is 13, yeah, and 13 times 7 is 91. Okay, so we've worked out a pattern here, right? The pattern is that the exponent here, not exponent, the multiplier here, the factor here, is the multiple of the other numbers. But what we really want, right, is the number after, because we're going to be substituting in n equals 0 in order to get the smallest number. What we want is this residual value, this plus 37. So how do we get that? That is what we want to find out. How do we get this 11 and how do we get this 5? 7a equals 13b plus 12. Seven times, okay, if I substitute in these values, maybe I can work it out backwards. This is like high school maths where you're not sure how to actually solve it, but if you get the answer, you can kind of work backwards to figure it out. 7 times 13 is 91n plus 77 equals 91n plus 13 times 5 is 15, 60, 65 plus 12, which is also 77. Ah! Of course. But since we're substituting in 0 for n, we don't care about n. So what we're actually looking for is that 7 times a, our value for a basically, has to equal 13 times b, which is plus 12, which is what our original question was. I'm seeing some mod stuff going on here though. Both 5 and 11 are 2 less than 7 and 13. Now is that a coincidence? Oh, wait, hang on a second. So A is multiples of 13, but starting from 11. B is multiples of 7, but starting from 5, or in this case, starting from minus 2. A is 37, B is 19, and C is 13. And my multiples were 7 13, and 19. You know what I've noticed? These are all prime numbers. I wonder if that's a coincidence. But then 7, 13, and 19 are also all primes. But 37 is a prime, isn't it? 37? Yeah, this time feels like a prime. 19 is a prime. 13 is a prime. Ah, but 824 isn't a prime. So that breaks that theory. Here it says D equals 8 to, I can't highlight it. It says D equals 824. So that breaks that theory. Oh, I feel like I'm so close. This is so tantalizingly close. How did it get these answers? Can you like explain in WolframAlpha? Is that a thing? Show me how to get integer solutions? I might just have to give up on this. Oh, I'm gonna be so dissatisfied. Okay, we'll go back to small. Maybe I'll still be able to figure it out. Maybe I can do like solving for integer solutions. You know what? Let me draw it on the graph again. Maybe it's the y-intercept and x-intercept. Oh, whoops. What happens at (13n) plus 11? No, right? A equals 13n plus 11. we're looking for x equals 13n plus 11. We're also looking for y equals 7n plus 5. How do these lines interact? Yeah, that crosses at 11. I don't think that means anything. Yeah, I feel you, Blue Ghost. I feel like there is a straightforward numerical theorem that tells us how to do this. But like if you're not a maths major, you probably haven't come across it. You know what? Like I think I'm being silly here. Because there's no way yeah. That 11 and that 5, that's the answer, right? so of course, every 13 numbers, a will be repeated. Like a will be an integer again, because that's just how the maths will work out. The question is, how do you get that 11? How do you get that 5? And if you had that, if I had that, I have the answer to part 2. So like the whole point is to work out how to get that in this result box. The whole point is to work out how do you get that 11 and how you get that 5. If you have that, you have the answer. What if I just said solve it? Not over integers, but just solve it. Right, so there should be an integer solution at 11 and 5, right? Yeah, so there is an integer solution at 11 and 5 right here. And that's what we're trying to find, right? The first integer solution. Maybe we can Google that. Finding integer solutions. Simon's favorite factoring trick. Diophantine equations solved by factoring, especially the second example, which is how to deal with cases where coefficient of the cross term is not 1. We want to do something equals 0. 7a plus 13b minus 13b minus 12 equals 0. 7a minus 13b equals 12. Or we cross multiply, right? We want to, oh, how do we, no, we can't do that. Seven x minus 13y equals 12. But that's the same equation, right? Like, it has to be the same line. It's the same equation. It can't not be the same line. Okay, so it looks like there's something to do with Diophantine equations. Oh, wait, hang on. Solve by factoring. There was a solution here. That, you group it, go x equals this. Since x is an integer, 3y plus 10 must divide 13y plus 35. But also, three times that must equal that minus 25. And so 3y plus 10 must divide minus 25. Oh, I don't want to sign up. Now we know that we know that x and y are integers. So x plus 2 and y must be integers that multiply to 6. I.e. two factors must be those. Well, we're not looking at this one, right? Let's hit the second one. Solving by Simon's favorite factoring trick, SFFT, also called completing the rectangle. But I think these aren't like what we're working with aren't Diophantine equations. Maybe I just want more examples. Let's just do like this as an example. Right, now in this case, they both have a plus 12 on the end, and that means they cancel out. And so 0, 0 is the equation here. (18 and 6). 18 minus 6 is 12, but I don't think that's got anything to do with it. I want two equations with different factors. Maybe I can chuck in smaller numbers just to see how it works out. I'll use primes. I can't, no, it can't be plus 7. It has to be a number smaller than it. We've got 3a minus 5b equals 1, I think. You put 2 in there and you get, what, 6, 8 on one side and 8 on the other side. Two is 5 minus 3, and 1 is 3 minus 2. Is that a coincidence? That's 7, that's 6. No, I still can't do it. I'm not sure. Well, I'm gonna be so dissatisfied. This video is like 1.5 minutes long now. 1.5 hours long. Let's look that up. Chinese remainder theorem. Blue Coast suggests looking at the Chinese remainder theorem. Pairwise coprime. Let n1 to nk be integers greater than 1, which are often called moduli or divisors. Let's denote n the product of ni. Yeah. The Chinese remainder asserts that if the ni are pairwise coprime, and if a1 to ak are integers, what's a? All right, such that a is between 0 and ni for every I, then there is only one and only one integer x, such that 0 is between x and n. And the remainder of the Euclidean division of x is ai for every I. This may be stated in the following terms of congruences. If the ni are pairwise coprime, but they have to be pairwise coprime. Is that the case? I guess all these numbers are prime numbers, as far as I can tell. I'm just glancing at them. Like all the small numbers are prime numbers. Actually, they are all prime numbers. So this could be it. Hey, Blue Ghost, I think you might be onto something here. So I think, I'm not a maths major, so I'm guessing, but I think pairwise coprime means that every pair of them, like relative, yeah, like it says here, relatively prime, right? Every pair of numbers have to be prime, like as in they don't share factors. But if all our input numbers are prime, then they can't share factors no matter what. Computation. Search by sieving. All right, we can search by sieving. Ah, now I'm like, how do you say this word? It doesn't say. Sieve. So sieving, maybe? I'm gonna avoid saying it. Suppose without loss of generality that AI is within Ni. Yeah. This means that solution belongs to arithmetic progression A1 plus N1, A1 plus 2 N1, which was the solutions that we found on WolframAlpha. By testing the values of these numbers modulo N2, one eventually finds the solution X2 of the first two congruences. Then the solution belongs to arithmetic progression. One eventually finds the solution X2 of the first two. Okay, so I think this is it too. Oh, you found how to do it on WolframAlpha? Nice, Blue Ghost. I think I'm gonna try and solve it. Like I'm gonna actually try and solve it properly. Yeah, cool. No, so I'm gonna try and solve it properly. So I'm not gonna read the solution that you're gonna post, or you've already posted, Blue Ghost, since there's a bit of a stream delay here. But given, well, I guess I have to do this like a little bit manually anyway. 13b plus 12. So this is giving me the solution 11 and 5, which means 77 is my first number, right? So I think that means I can leapfrog off 77. One eventually finds the solution X2 of the first two congruences. Then the solution belongs to the arithmetic progression X2 plus N1, N1 times N2. Right, hang on. I might need a new piece of paper. But I think A1 is 0 and N1 is 7 for the first answer, right? Because that's 7a. And it's saying that once I have that, by testing these values, these numbers modulo N2, so I want to test all the multiples of 7 mod 13, right? And then 14 mod 13, 21 mod 13, and so on. I should find 12 at some point. 28 mod 13. Yep, so if I keep going, I think I won't find 12 until I get to, whoa, all right, so Blue Ghost just said that he solved it in 1 hour, 20 minutes, and he still got 2,000th. So yeah, this is a really, really tough question. You really need to know your maths to be able to do this. So I'm gonna try and keep going. I think I'll solve it in the next 15 minutes if I'm lucky. 63 mod 13 is 11, 70 mod 13 is 5, and then 77 mod 13 is 12. So I found my next answer is 12. Okay, so I'm going to stop this because it's like eating so much CPU, and I don't think I'm going to find an answer that way. So I found 12. 77. So 77 is x2, right? x2 is 77. So it's saying that if I start from 77 and I add n1 times n2, which is 13 and 7, 13 times 7 is 91. And then I can mod the next number on that, is what it's saying. So I'm going to try it with 19 plus 12. So I'm going to start from 77 mod 19, and I'm trying to get to 12, right? 77 plus 91 times 1 is 612. Times 2 is 12. And that answer is 259. Now, is 259 the answer? If 259 is the answer to this, then I think we've got it. 37 times, so 259 divided by 7 is 37. All right, so we've got the programmatic solution to this, thanks to Chinese remainder theorem and this bit of what do you call it? Wikipedia. Wikipedia, great source. We should use it more. All right, so we're not searching for it anymore because that's not going to happen. But I believe these targets are still relevant, right? Whoops. Yeah, example. We're using an example input to do this. Cool. So search. So function search, given the divisor and the remainder that we want to get, we basically want to go for I equals 0, I less than, well, we're just going to keep going. For I equals 0, I mean, you should always find it. I less than divisor, but you should always find it. I plus plus. If 13, 12, 59, 55. Yeah. So if what's the equation? Divisor no, this isn't enough. We need to have our continuous solution as well. We have x, and we have I know what I want. I just have to put it together. Hey, Blue Ghost, you're always helpful. Like all your help so far, right? Even with the JavaScript stuff, it's been amazing. So yeah, it's great. There are like 4 variables we need to keep track of here. No, for each target, right? Okay. And we have C. Okay, I'm gonna call it X and C. I think that'll be okay. So we want C plus X times I. Yeah, it's gonna be cryptic because I don't know what to call these things. So that's our value. So our test value is this. So if test mod divisor, if that equals remainder, that means we've found it. Equals remainder, then our test value is the answer. So we want to return test. So for example, if I search for 13 and 12, which is the second one, because I need it, and the answer to the first one was 77. No, 77 goes in C. And this is 13 times 7, which is the multiple of all the divisors that we've gone through so far. So that shouldn't be 77. That should be 259. X times I. That's 77. 77 mod 13 is 12. Why is 77 mod 13 12? Ah, no. This is the next one. This is, we want 50, no, we want 19 and 12 for this one. That's 259. So for the first round, we want 13 and 12. This is just 7. And we start with 0. Cool. And so for the first round, I'm guessing this is 7, this is 0, and this is 1. So that's 0. So then we chuck in 13, 12, 7, which is 1 times 7, and the answer to the previous one, which was 0. That gets us 77. We chuck in the next one, 59, 55, multiply that by 13, which is the previous one. Our answer was 77. That gets us 350. So the answer, so now we go, the next one is 31, 25, multiply 59, and our answer is 350. 7 that. Okay, cool. And then the next one is 19, 12, multiply that by 31, and our answer to that was 70147. That gives us 1. That's the answer. So that is the algorithm. It's actually a really quick algorithm. Once you know what you're doing. But I'm just trying to bring all my, I should have done this one at a time. So I have all my answers. So that's the regression to find it. So now we just need to write this into a loop. For const, I guess we go factors, right? Div rem of targets. Is it targets? Targets, yeah. Let prod equals 1. Let answer equals 0. Answer equals search div rem prod answer. Prod times equals div console.log answer. Seems to be the loop that we've built here. Yes. And so theoretically, if I chuck this as the actual input, it should spit out the actual answer. Is that it? Is that it? Oh, wow, that's super cool. Yeah, no, there's no way I would have been able to work that out like by myself. Yeah, I got 2,400. And I did solve it in 15 minutes, like I guessed. Dang, wow, Blue Ghost, thanks for your help. That Chinese remainder theorem helped so much with like the actual solution. Oh, do I think I could have worked that out by myself? I doubt I could have worked that out by myself, man. I am sure I wouldn't have been able to do it. The idea there was like you could basically search like so the implication here, right, is that an answer for 3 variables is going to be the same as the answer for the first 2 variables. Like you can it's like what's the word, associative? Yeah, like this whole problem is associative, right? You can like oh yeah, well, Lucas, if you show me how to do WolframAlpha, I'll just chuck it in there and see how it works. Because I couldn't figure out the it wouldn't do more than seven like 7 variables for me, and I couldn't figure out a syntax to make it do all 9. Yeah. So anyway, it's kind of basically saying the answer for any two of the bus timetables, right? You can kind of group them together and solve just 2 of them by itself, and then the answer to that, you can use that to solve for the next one, and then the answer to that you can use to solve for the next one, and the answer to that you can solve for the next one, and so on, which is why this sort of loop here works. I can't really explain it because I'm literally just I literally just read this search by sieving thing, and I just implemented what it says here as an algorithm, and that's all I did. So yeah, being able to read like mathematical texts is a pretty good skill to have. It says Blue Ghost says all you have to do is get rid of the multiple variables and the solve of integers. Just write it out and it will just do it. Are you serious? Oh, I was trying to like help WolframAlpha too much apparently. All right, let me just try it. So, oh, that's gonna be pretty hard to write out. What's my thing? I think I have to write it out like this, right? 41a equals 37b plus 2 equals 557c plus 516 equals 29d plus 15 equals 13f plus 11. I'm skipping e again. 17g plus 10 equals 23h plus 5 equals 419i plus 347 equals 19j plus 4. Well, it gave me an instant solution here anyway. So yeah, so I guess you could write it out with the mod. Just typing in the equation after I had worked out all the moduluses as well seems to work. And so this should give me the same answer, right? If a is, I'll type that out over here. Oh, I can use t's. Yeah, but then like doing it this way, yeah. So Blueco says, yeah, I guess it works too. But I guess doing it this way is a bit more work, right? Because I had to actually work out those modulos by hand before, like in order to type it in. So we just check 1459539783980 times 41 should be the same number, and it is. Ah, right, yeah, if you use t, it'll just give you the answer. True. Makes sense. So yeah, actually so I guess another takeaway from this, right, is sometimes, so WolframAlpha is an amazing engine, and it does way more than a lot of people realize. Like the fact that you can take a question like this, right, and you can literally just basically put the question straight into the text box and it just spits out the answer for you. Like what kind of magic is going on behind the scenes in order for them to parse, like not only parse your equation, but then like figure out what you want to do with it and then give you an answer that is meaningful, right? Yeah, the guys behind WolframAlpha are like crazy amazing. Anyway, this video has gone for long enough. It's been a really cool question. I learned something new. Don't know if I'll ever be able to apply it to anything, but if I ever need to find a number that's divisible by a lot of different numbers modulo some like different numbers, I guess now I know how to find it. So thanks for joining. If you stuck around all the way to now, you're an amazing person. Cool. I guess I'll have to make a comment about like all the timestamps because otherwise it's just gonna be hours of me like scratching my head. Thanks for joining. I'll see you again tomorrow. And huge shout out to Blue Ghost for figuring this for helping me out.